consists of these students from ITS, 5 students from ITS, and from Kumamoto University, 2 students. And group number 2, again, 5 students from ITS and 2 students from Kumamoto University. Group number 3, 5 students and 2 students also from Kumamoto University. 4, 5 students from ITS, 2 students from KU. And group number 5, 4 students from ITS and 3 students from KU. Later, you will have an in-class activity that will be managed by Dean Aviso. So please follow this grouping. Please go to your group. So remember your group number. You will join your group number later during the in-class activity. Okay, so let me stop sharing this one. Regarding your homework, you will also have a group homework. So you will do the homework in collaboration with partner universities. So ITS students will collaborate with Kumamoto University students and vice versa. This is a brief explanation of the homework. Okay, so you will have, I hope I'm sharing the right slide. So it's 1 submission per group, 1 submission per group. Group number 1 will submit 1 homework, all right, your answer to the homework. The deadline will be October 22, that's a Friday. So ITS students will submit your homework, the same homework, okay, to Dr. City, and the KU students will submit the homework, the same homework that you did in collaboration with ITS students via Moodle. So I hope this is clear to everybody. So let me stop sharing this one. And well, I will upload this information about homework in Moodle, and I will also share it to Dr. City. So, all right, so let me introduce this time the lecturer for today and for next week. So Professor Kathleen Aviso. So Professor Kathleen Aviso is now the Dean of the Gokongwei College of Engineering of De La Salle University. She is a professor of chemical engineering, also specializing in LCA, actually computational analysis and so on. So LCA, life cycle assessment and so on, especially in relation to, but I should say environment, climate change, and biomass utilization as well. So, well, this is just a brief introduction. If I introduce Professor Aviso, it will take the whole class. So that's just a brief introduction of Dean K, Dean Aviso. Without much further ado, I will give this virtual microphone to Dean K. Aviso, please.
Thank you very much, Dr. Kitain, and good afternoon, everyone. Thank you for joining this class. So let me just share my screen. Sorry, Dr. Kitain, can you enable screen sharing?
Okay, sorry about that. Oh, multiple participants can share simultaneously. I think you can.
Okay, now I can. Thank you
All
so
right,
much.
okay. So please allow me to record the video because I'm going to share it to Dr. City for those who cannot attend because of the Friday prayer. All right.
Oh,
so
I see, I see.
please,
Okay, so
Dr.
let me just look for my window. All right.
Recording in progress.
Okay, so I hope that everyone can see my presentation. So like what was mentioned by Dr. Kitain, part of my work is really on environmental issues and life cycle assessment and developing mathematical models for environmental decision making. So for this particular lecture, I decided not to go too much into details of the computational aspects, but more of an appreciation of our environmental issues as well as life cycle assessment. So I come from Salle University, Manila, Philippines. So unfortunately, because of the pandemic, we are unable to visit each other's campuses. But hopefully when we're back to normal, if ever you get the chance to travel to Manila, I hope that you will visit our institution. So Salle University is currently ranked the first of the Philippine higher education institutions in terms of Scopus Index publications since 2019 until the present. So we're very proud that we have managed to improve our research output by up to 600% in the last 10 years. Just recently, we were included in the Times Higher Education World Rankings. There were only 2 institutions in the Philippines that made it to the rankings, and De La Salle is one of those. And we're the only private institution that made it to the rankings. So that's just a brief introduction about our university. And we also got into the Times Higher Education subject ranking in terms of engineering and technology. So the institution, which you saw a while ago, is located in the heart of Manila. So the picture is on the upper left-hand corner. So that's our main campus. But we do have other campuses. We have the Laguna campus in Binyan, Laguna, which is located in the outskirts of Manila. It's a bigger campus. It's a 50-hectare campus, and it's currently referred to as the Science and Technology Complex. So eventually, our labs will be stationed in Binyan, Laguna. So there are several buildings there that are really dedicated for research. We also have the Rufino campus, which is located also in a city nearby Manila. But that primarily houses our College of Law and College of Business. Okay, so this is just some pictures of how the 50-hectare campus in De La Salle, Laguna looks like. So these are the facilities. So we have our central instrumentation facility there and other laboratories which require really big equipment. Okay, so before I begin, so I would like to invite everyone to join me in this presentation. So it's currently uploaded in menti.com. So I have a few slides that will require your inputs. So please scan the QR code or go to the link menti.com/NRRS4ZVGMH. And I think, I can't see it from my end, but there's an ID code that is listed on the top of the screen. So you can just go to menti.com and then type the code there. Okay, so I hope that you guys are able to check that one out. Okay. So here are the objectives of this particular lecture. So essentially, I want you guys to understand the environmental impact associated with products and processes, and to gain a thorough understanding of the basic concepts of life cycle assessment, and to learn exactly how life cycle assessment can be utilized by industries in their decision-making, or maybe even by consumers in the way that they make decisions with regards to selecting products, or maybe if you're an industry and you wanted to change a technology, then you can also utilize some LCA concepts to make your decisions. So this is the outline of my presentation. So we'll have a brief overview of sustainability issues, and then I'll discuss a little bit about biomass conversion technologies, primarily because this course is on biomass utilization. So we'll look at some aspects of biomass that are relevant with regards to addressing sustainability issues. And then we'll look at the fundamental concepts of LCA, its historical development, some other qualitative descriptions, and its practical applications. And then I'll end with a summary and conclusions. Okay, so before we begin, so I hope you guys are on menti.com. So I just wanted you to input if you can name a very important environmental issue. So I think you can input up to 3 different different issues. So we'll just create a word cloud. So I just wanted to see your inputs. What do you guys think about when you hear environmental issues? So can you start it? I can start the countdown. Although, yeah, I think, can you guys try inputting and see if you can already put in your comments. So can anyone try it out? Yeah, don't be shy. There we go. Thank you for that. Yeah, keep on keying in. Yeah, that's good. Okay, good. What about the others? What about the others? Okay, we'll have about a minute and then the voting will close. So please input your ideas when it comes to environmental issues. So we have global warming, greenhouse gases, water pollution, and waste disposal. Okay, are there anything else? Is there anything else that you think about when you look at the environment? What are some of our problems today? Okay, water pollution, yes. Especially now, no, with the COVID pandemic, do you think that it has helped our environment, or did it improve our environment? Yeah, good. Okay, that's great. So 10 more seconds. Climate change, yeah, deforestation, good. The air pollution. Okay, so thank you for all those who sent in their comments. So the biggest one is water pollution. It means that I think a lot more of you actually placed this particular comment. And I see here that there are several issues that are actually related to each other. So we can see greenhouse gases, climate change, and global warming. They are more or less connected to each other. So thank you for that. Okay, so in 2009, so just to give you an overview of what are some of the pressing environmental issues that we are facing today. So in 2009, the group of Rockstrom published an article in Nature which proposed different indicators which tell us that these are what are necessary so that we can sustain life here on Earth as humans, you know. So these are the indicators. There were land use change, freshwater use. So some of the vital things that we would need to survive. So in there, I think somebody's, thank you. Okay. So climate change has been considered as one of the major environmental issues for which we have identified safe limits. So for climate change, the safe limit that was indicated was in the concentration of greenhouse gases in our atmosphere. And a lot of scientists are actually monitoring this already. The recommended concentration is 400 parts per million, but we have actually already exceeded this. So, and the complex thing about climate change is that a lot of other environmental issues are actually linked to it. So because of the change in climate, it actually affects our biodiversity. It also affects the availability of our resources. And so even if we just focus on climate change, it actually impacts several other aspects of the environment. So here are just some of the issues that have been identified in the 21st century. So we mentioned climate change. Of course, we have resource depletion by virtue of the increase in our population. And since we always have needs, we always have demands, we always have products that we consume. And those demands require a lot of resources. And some of our resources are not unlimited. It means that they're only a certain amount is only available here on Earth. So our resources on fossil fuels that we need for generating electricity is reducing. There is a reduction in the availability of water and food. Some of our resources, like minerals that are non-renewable, are currently being depleted. And of course, soil and land. So as the population grows, we can imagine that we consume more land because we consume more space. We need more space where we can live. We need more space so that we can plant food for our own needs. Other issues are biodiversity. And of course, you guys also mentioned pollution, air pollution, water pollution, land pollution, and wealth inequity. So these are just some examples. Okay, so since we've mentioned some of the environmental issues, so I just wanted you to rank them. What do you think is the most important, which we can rank as 1, and which among them would be the least important, which you would rank as 5? Okay, so kindly type in so we can see the, so we can see the preference of the group, or what's the idea of the group when it comes to environmental issues. Okay, so you just need to go back again to menti.com and type in the code 79312517. Please don't be shy. Okay, great. That's great. Okay. Others? All right, good. Nice. Okay, so I'll start the countdown. So you have a minute to key in your responses. Okay, that's good. Anyone else? I think I have 10 responses. Okay, 11. Yeah, it's kind of a giveaway for number 1. I think I already, I mentioned that too early into the presentation. But yes, but I believe that climate change is really the most important environmental issue that we are facing today. But of course, it's not the only issue. And there are so many other things. I just put here 5, but there's so many other things that we can think about. We used to think about ozone depletion and acid rain. Yeah, I remember back in the days that people were concerned about acid rain and the ozone. Okay, thank you very much. So a lot of you rank climate change as the first one, and the second one would be water pollution and its scarcity. Yeah, and I think it really matters to us, as human beings, because these provide us with some of our basic necessities. But this particular exercise also shows us that, which later on I will also emphasize in life cycle assessment, that there are so many environmental issues around us. And as decision makers, sometimes we need to prioritize because we only have limited resources to try and address the environmental issues. And it might not be enough to address everything. So this is an exercise that shows us that sometimes that prioritization also relies on our decision makers. And what the decision makers actually need is a decision support tool to help them decide on the ranking, on which one they should put priority more, or which one should be more important for them. So because of the issues, or because of the awareness of these environmental issues, we advocate now sustainability. The main 3 pillars of sustainability is not just about environment, because as humans also, we also want to make sure that we continue to develop as a nation, maybe as a country, as an entire global community. And so part of it is economics. And of course, since these would impact society, we should also include ethics. So these are the 3 pillars of sustainability. And so any any strategy to try and address environmental issues tries to look at these different aspects. And now we actually have our sustainable development goals, which look at these aspects on a global perspective, looking at the different problems that we have globally and trying to, prioritize or emphasize which ones would be most important. And I think this is a good guiding principle as well. If you wanted to do research, for example, in a particular field, maybe your research addresses some of these sustainable development goals. And in that way, if you conduct work in this particular field, then you're contributing towards achieving sustainability. So as engineers, as an engineer, we always want to look at how exactly can we contribute as engineers so that we can reach sustainability. So of course, different kinds of disciplines would have different expertise. And as engineers, typically what you do is you try and find engineering solutions for a particular problem. So as engineers, there are two fundamental types. First would be trying to design industrial systems so that they can be more efficient and green. Because I think everyone can understand that most of these environmental issues have arisen because of industrial activities. So we were, uncontrollable use of resources so that we can provide the demands of the community. But perhaps if we can design products, if we can design processes, maybe there is a way to find more sustainable processes so that we can still enjoy these products, but with better environmental impacts. Another one would be selecting the best technology or management action for a given application. So it's either designing the system or selecting a particular technology, because there are so many ways to get a result. And as engineers, what we want is to be able to select which would be the best technology that can achieve our goals and at the same time improve the environment. And to be able to do that, we need, of course, some indicators so that we can monitor and really measure and compare between these available technologies. So some indicators include concentration-based. So some of you mentioned water pollution, So one way to evaluate water pollution is to check for the concentration of contaminants in the water. So that's a concentration-based metric. Others can be in terms of efficiencies, because we want to generate as much products, but with reduced resources. And by doing that, we can actually reduce the consumption of resources and also reduce the generation of waste and the generation of other emissions. So such efficiency-based metrics can be in terms of amount of carbon dioxide produced per kilowatt hour of energy generated, or if it was a transport vehicle, we would want a car that can travel with less carbon dioxide emissions per kilometer. While other indicators can be more on a macro perspective, looking at gross domestic product or the amount generated per person in a particular country. Right? So this illustration on the right is an example of, I'm not sure if you've heard about environmental or ecological footprint. So that's why it looks like a foot. But essentially, this is just an illustration of how much resources it takes for an individual, an industry, or a company to perform its activities. So, long ago, the focus to address environmental issues was really on pollution control mechanisms. These were treatment technologies and disposal technologies. And that the emission has already occurred, and the strategy was try to control these particular emissions. But now we have moved on to the upper tier of the triangle, where we want to focus on cleaner production such that we can avoid the generation of waste and the consumption of resources at the very, very beginning. So we try to prevent the generation of waste through the design of our processes, maybe utilization of more efficient technologies. And so we look at source reduction and recycling and reusing. And they have found that it's possible, that maybe it's possible to actually have both environmental and economic benefits. Because if we reduce the consumption of resources, then in a way you are also reducing the associated cost for acquiring these resources. Okay. Okay. So now let's move on to today. Like what's in it today? What are we trying to accomplish? So now the challenge is to make sure that the increase in temperature is maintained to below 2 degrees Celsius. The target is to try and keep it at 1.5 degrees Celsius. It seems like a very small change, but it actually has great impacts globally. So I'm not sure if you've heard about melting ice caps already. So all of these are really consequences of the increase in atmospheric temperature. But how do we actually do that? How do we make sure that the temperature doesn't increase further? So some of you actually mentioned greenhouse gases and global warming. So it is the generation of greenhouse gases such as carbon dioxide, methane, that result in global warming. It is the increased concentration of greenhouse gases in the atmosphere that creates a blanket that prevents, heat from radiated heat from the sun from going out of our atmosphere, and as a result, it becomes warmer for us. And that's the main reason why our focus has been on reducing carbon dioxide emissions, essentially reducing production of greenhouse gas emissions, so that we can keep the increase in temperature to as low as possible. Okay, so this is the next question that I have for you. So I want to get your ideas. What do you think are some strategies that we can do so that we can reduce carbon emissions? So just key in your ideas. There are no right and wrong answers. So I just want to gauge what's your awareness of carbon emissions. And because we can't do our contribution unless we are aware of how we can do it. So please key in your responses. I think this is like an open-ended question type. So you can type in more if I'm not mistaken. Okay, there. Okay, limit meat consumption. Oh, that's interesting. That's good. What about the others? Okay, not to use plastic materials. Okay, what else? Okay, good. Consume local products, reuse shopping bag. Okay, very good ideas. Okay, implement carbon dioxide reduction technologies, I suppose. Yeah. Okay, so let me start our timer again. So what about the others? Type in your responses. Okay, reduce waste, prefer recycling of products. Yeah, good answers. Okay, use public transport. Yeah. So I'll touch upon some of your responses later as soon as more responses come in. Use biomass. Okay, like biodiesel. Good. Perfect for this particular course. Good. Any other ideas? I just have 8 responses. Okay, change from fossil fuel, to biomass energy. That's good. Okay, carpooling. Good. Reducing the use of yes. Okay, sustainable. Yes. Okay, good. Okay, use hydrogen energy. That's good. All right, so the voting is closed. So thank you so much for your responses. So I think you're very much aware of our problems on carbon emissions because you put in a lot of ideas here that are really, you know, some of the strategies that we can do. So we can limit meat consumption primarily because you need a lot of resources so that you can farm meat, and at the same time they also generate a lot of methane. Well, the cows generate a lot of methane. Consuming local products addresses carbon dioxide emissions because it reduces the amount of emissions that you generate from transport. So later we'll have a look at that as well. Yes, use of public transportation instead of, you know, everyone having his or her own car when you're going to the same place. So at least if you just use one bus, it's just, you know, one, either a bus or a train, you know, it's just one thing that's generating emissions. Same with carpool. And of course, we have the renewable sources of energy, such as biomass and hydrogen energy, which do not generate greenhouse gas emissions when you use them. And then we have this technology, carbon dioxide removal. So I wonder who's working on that. So it's really removing carbon dioxide from the atmosphere. So thank you so much for your response. So yeah, so I'm not sure if you've seen this technology wedge for carbon management, but it tries to identify different strategies that we can do as a collective so that we can reach carbon neutral by 2050. So what I like about this particular illustration is that it tells us that it's not just one technology. We need to combine our efforts. It's not just, you know, a one time, there's no one cure. So it's really a combined effort of all these technologies. So you can see the trajectory of what will happen when we stay on our business as usual. So it will keep on increasing, but our target is here at the bottom. So some of the things that you mentioned are actually included here. So carbon dioxide removal, use of renewables, and so on. So what I wanted to highlight is that improvements in energy efficiency and can actually contribute more than half of the reductions. So the main result of high carbon dioxide emissions is really by virtue of the large amount of energy that we are consuming as a population. You know, so just by improving efficiency, we can actually make a difference. Okay. Others say that we need more innovative technologies so that we can further reduce emissions. And these are called negative emission technologies. So it's not just reducing emissions, it's not just zero emissions, but it's negative emissions. And these technologies include bioenergy with carbon capture and storage, carbon capture and storage, direct air capture, biochar, and enhanced weathering. So maybe we'll touch upon some of these technologies later on. Okay, so when it comes to biomass, I think they can contribute in these particular aspects by using biomass for fuel and combining it with carbon capture and storage. And then we can also implement the biochar technology. So what happens exactly? Because when we make use of biomass as energy inputs, so we have avoided emissions because we avoid the use of fossil fuels. And we know that biomass is a net zero emitter because it just consumed carbon dioxide from the atmosphere to become a plant. And then if you burn the plant, so it's just a net zero. It's equivalent, like what it took in from the atmosphere will just be released. But if we combined it with carbon capture and storage, then whatever it used as a plant will not return back into the atmosphere. And that's why it's considered as a negative emission technology. Okay, so let's have a look at biomass conversion technologies. So just just to focus a bit more on what biomass can do for us. So these are your biomass resources, and these can actually be converted, transformed, or processed using different technologies. And some of these technologies include pyrolysis, gasification, combustion, co-firing, and so on and so forth, to generate new kinds of products. So it can be energy products, but it's not limited to that. It can be high value chemicals and so on. Okay. So how does it contribute? So if you remember our technology wedge, biomass can help improve energy use efficiency through the generation of electricity and heat and implementation of more efficient combined heat and power technologies. They can also generate higher value products and result in negative emissions technologies. So if you can recall, the biochar, which we had earlier, is actually similar to charcoal. So what happens is that you capture some of the carbon content of the biomass in your biochar, and as a result, again, it doesn't go back into the atmosphere. So again, it's a net transfer of carbon dioxide emissions from the atmosphere to the biochar. Okay, so maybe we'll talk more about this next week. Okay, next week we'll do some optimization. But anyway, so for us, we've tried to use this information to look at possibilities of the different technologies and how we can reduce our carbon dioxide emissions as a country. Unfortunately, based on our work, our commitment as a country, which was 70% reduction, cannot be met by current available measures that we have in the country. So we really need to be more innovative. But this kind of analysis can help us identify whether our targets can actually be met and whether we need additional strategies to reach those targets. So for the Philippines, we do have a lot of biomass. I suppose it's similar to Japan as well as in Indonesia. And by utilizing these biomass, or by maximizing their use, then we can create big potential for addressing carbon emissions. So I mentioned about biochars. I mentioned it to you a bit a while ago. So like I mentioned, what happens with biochar is that you have the biomass, you process it using pyrolysis or gasification technology, and you extract the energy, the gasified section of that particular biomass, so that you can use it to produce electricity, but you also generate solid matter, which is biochar, and so you trap the carbon in your biochar. And what they found is that you can use this as a fertilizer or a soil conditioner. So it's like you have multiple benefits from it. And if you put it as a soil conditioner, it can increase also the production of your crops. However, this particular technology is still under research. So people are still investigating if it can how it can be implemented on a wide scale. But there is potential for 130 gigatons of negative carbons just by the use of biochar. Okay, so here are just some advantages and disadvantages on the use of biochar. So it can sequester carbon in soil, can improve soil quality, can mitigate greenhouse gases. Because of its soil conditioning capacity, it reduces fertilizer requirement and water demand for plants, and can immobilize heavy metals in the soil. However, it can introduce some harmful chemicals or harmful impurities that are present originally in your biomass. And at the moment, it's not economically feasible because it's relatively more expensive than traditional fuel. Okay, so the good thing about biomass conversion technologies is that we know that biomass is abundant anywhere in the world. It is estimated that it can actually supply up to 25% of primary energy demand. So there's a big potential for reducing the use of fossil fuels. If we use co-firing with biomass, this means that part of the fuel you use is coal, part would be biomass. It doesn't really require major capital investments because the same technology can be used. You just need to add maybe additional equipment, but you don't need to build a plant from scratch. Okay, so it's a relatively low risk option if we implement biomass utilization at low percentages, maybe 10 to 15% co-firing. Okay, so this is just a description of the different co-firing technologies. So you can either make use of direct co-firing or indirect co-firing, and some of the advantages and disadvantages of these technologies. So I'll just show you an illustration of the difference between the two. So at the moment, we make use of coal for generating electricity. But like I said, it's possible to reduce the utilization of coal if we can combine or we can replace some of that coal with biomass. And to do that, we need to retrofit our current power generation technology. And there are two ways we can implement direct co-firing or indirect co-firing. So just to illustrate what's the main difference between the two, it's essentially how biomass and coal are burnt. So if it's direct co-firing, it means that the two are combined directly and are combusted within the same furnace. But if it is indirect co-firing, you can see here that the biomass initially undergoes gasification so that it collects the combustible gas. And it is that gas that is taken to the furnace to be combusted together with coal. So like I mentioned in the previous slide, there are advantages and disadvantages to these technologies. And so one needs to assess also which one would be the best option. Okay. And the field that I'm in is known as process systems engineering, which is the development of mathematical tools or models to try and plan out how such technologies can be implemented on a wider scale. So this is just some of the work that we've done on how biochar production and what do you call this, amendment into the soil amendment can be implemented so that you can maximize the benefits from the biochar. Okay, so I'll just go through this quickly. Okay, so now that we have some idea on available strategies and some technologies and some options that we can actually visit when we want to implement a particular, when we want to meet a particular target. Of course, we can only do this if we have quantitative tools to actually measure and manage the environmental impacts of these technologies. So we need quantitative tools so that we can track our emissions and find benchmarks for effective decision making. And this is where life cycle assessment actually comes in. So I'm not sure if some of you have heard about carbon footprint analysis as well, but it is similar to life cycle assessment, and they share the same perspective on how to calculate environmental impact. Okay, so as an introduction, what exactly is life cycle assessment? So CTAC defines it as an objective process to evaluate the environmental burdens associated with a product, process, or activity by identifying and quantifying energy and materials used and wastes released to the environment to evaluate and implement opportunities to effect environmental improvements. What I think is important about life cycle assessment is understanding the holistic perspective it brings. So you can see here on the right-hand side is an illustration of how life cycle assessment proceeds. So it actually accounts for all utilization of resources and generation of emissions from the very beginning of raw material extraction, material processing, manufacturing, product use until the end of life. So it doesn't just focus on the production of your products, but actually tries to trace back where your resources came from, how were your resources obtained, and look at what were the emissions or what were the environmental impacts that may have happened when you tried to acquire or get that particular raw material. So here are some thoughts that life cycle assessment can actually address, or maybe some thoughts that you can think about. Do you think that there are environmental impacts associated when you send a message using your mobile phone? Do wind turbines, solar cells, and hydro plants generate carbon dioxide emissions? So how green are electric cars? Are paper bags really better than plastic bags? And does burning biomass generate carbon emissions? So these are some questions which life cycle assessment can actually answer. So just to know again your thoughts. So now that you're more or less introduced to life cycle assessment, which of the following do you think doesn't have carbon emissions? The use of solar-powered air conditioners, taking the school bus, searching online, all of the above, or none of the above? So kindly answer this multiple choice question. Okay. Okay, so I'll start my countdown. Okay, what about the others? We have 5 now. 5 people have voted. 6. 8. Okay. Okay. Ten seconds. You can still vote for those who haven't voted yet. Okay, time is up. So thank you for your answers. So hopefully the rest of the discussion will answer this question. But okay, just to tell everyone the answer. The answer actually is none of the above. Which of the following doesn't have? Yeah, none of the above, because like I said, what happens is that you need to consider all the activities that you do to produce a particular product. And if you actually examine all the activities that you need to produce a product, then somewhere along the line, you will actually find an activity that generates carbon. Okay? So this is the framework of life cycle assessment. And these are the main steps for conducting it. So the good thing about LCA is that it reveals indirect environmental impacts by virtue of it's like a supply chain, by virtue of the other activities that are happening outside of the manufacturing plant. It can provide a balanced consideration of different forms of environmental impact, like what we did a while ago, wherein we tried to figure out which environmental issue is more important. So LCA can help you also articulate, how to make a final decision. LCA can find hotspots. It means that it can identify which part of your production process contributes most to environmental impact. And if we can identify that, then maybe we can develop strategies that really address that particular environmental impact. It also provides a means for comparing alternative technologies or decisions. Okay, so here are some related concepts of life cycle assessment. I'm not sure if you've encountered some of them. But these would include life cycle optimization, life cycle management, and so on and so forth. So some have extended it to life cycle sustainability to include other aspects included in the pillars of sustainability. So these would include economics as well as social aspects. So environmental footprints are also very popular. This is also in a way related to life cycle assessment. So when we talk about carbon footprint, we're just really measuring the total greenhouse gas emissions or global warming potential of a process measured in terms of carbon dioxide and other greenhouse gases. But we're only looking at carbon. We're not looking at other impacts. We have water footprint that looks at the utilization of water. So it can be fresh water used, fresh amount of water consumed, and amount of polluted water generated. There is also the energy footprint, which tries to account total energy utilization because it is somehow related to carbon emissions. There is emission footprint, which tries to quantify the collective emission in terms of land, air, and water. We also have the biodiversity footprint, which measures the biodiversity loss due to land conversion, like when we change forests into agricultural land, or if forests are turned into housing or subdivisions. So we lose some of the biodiversity. So these are just some indicators which you can use as a decision maker. So who needs LCA? It can be used by anyone, by government policymakers for creating better policies, corporate top managers, process designers for selecting the technology that would be better environmentally. And maybe if you're a consumer who's very conscious about your environmental impact, then you can use this information to select which particular product you're going to buy. So yeah, we can just go through this. So essentially what LCA does is to provide a fair comparison between technologies or between products because it focuses on functional unit. What does it mean? It means that it focuses on the function of a product or a process to its ability to deliver a function when you measure its environmental impact. So it's not about one bag of paper bag against one bag of plastic bag. It's not like that. You have to look into the function. Maybe it's the function of carrying 5 kilograms of grocery for 1 week. Then that makes them more comparable. So you need to figure out now how many paper bags would you need to do that in 1 week, and how many plastic bags do you need to perform the same function in 1 week. And so it doesn't necessarily mean that you need 5 plastic bags and 5 paper bags at the same time. So those are some considerations that you include when you examine life cycle assessment. Okay, so let's just illustrate. So this is life cycle assessment. You need to think about where you got your raw materials, how these raw materials were processed, and then how were they transported to the manufacturing plant or maybe to its customers. So it includes transportation. Do you have some form of maintenance, reusing? How is it managed as a waste? Is it recycled or is it thrown already? So these are some things that you need to think about. And at each step, what you need to know is, did I make use of energy at that particular step? What other resources did I use? And then what emissions did I generate by doing this? So for example, for electricity production, if we made use of coal, then we need to think about how coal was obtained. So it would be looking at mining processes and what kinds of inputs does mining require. Did you require a truck? And did your truck generate emissions? So those are some of the things that you need to account for. And then the coal, do you need to grind it? When you ground it into powder or something, did you need to operate a machine that required electricity? And so you would need to account for the energy that you used. Did you need to wash it? Did you need water? So you also need to account for those. And then after processing, did it generate any wastewater? Did it generate air emissions? So all of these things would need to be accounted for when you look at a product or a process on a life cycle perspective. So this is just another illustration of how a typical life cycle system would look like. So there might be sections wherein you need to reuse or recycle materials. And so we can think about the results of an LCA like a nutrition label, wherein each category or each criteria is an environmental impact or environmental indicator. So, and you as a consumer would have to look at this list of information and decide whether that particular product is good for you or not. So if you're a consumer and you probably just look at total fat, it's similar to conducting an LCA and just looking at carbon footprint without consideration for all other criteria. So these are some of the limitations when we just look at carbon footprint, when we just look at water footprint. But in a way, it does provide us with some information and a baseline on how we can compare technologies and products. Okay, so these are just some example results of what happens after you've conducted an LCA. So you can break down the emissions on which particular phase of a process it happened. Was it in getting the feedstock? Was it in utilizing the vehicle? And so you can assess where particular emissions occurred most and how you can actually address them. So these are just sample. So this is a change, like comparing two different technologies and how particular impacts have increased. So this is sulfur dioxide emissions. So when it was compared, like maybe traditional compared to electric vehicle, there was an increase, a 400% increase. And by doing an LCA, you can figure out where exactly in the process did it happen. Okay, so this is just a brief history of LCA. It started with consideration of energy, concern about energy, accounting for energy, and later on extended into the inclusion of other environmental impacts. And today we look at stuff like carbon footprint, life cycle costing, life cycle sustainability assessments. And yeah, we've looked at this. There are different parts of the LCA. We have the goal and scope definition, life cycle inventory analysis, life cycle impact assessment, and then finally interpretation. Okay. So these are already in the ISO standards. Okay, so this is the process, but we shouldn't look at it as a very linear process. It's really an iterative process that might need to get adjusted every time we find additional information about our system. Okay, so the first one is on goal and scope definition. This more or less outlines how you intend to conduct your study and what is your main objective for conducting the study, just to make sure that all the data and all the calculations that you make will be aligned to that particular goal. Okay, so these are examples of how we can define system boundaries. Essentially, it's just setting which particular processes should be included. You can just imagine that if you try to trace the raw material of each component of your product, then it might be an unending, an unending system, because you'll keep on going back and back and back, and it might really be overblown. So you need to define which particular processes would be important for the objective of your study. Most importantly, you need to define your functional unit, which I already described a while ago. It's especially when you're trying to compare different processes, you have to make sure that the two processes that you're comparing are actually providing the same function, and which particular aspects will be included in your assessment. With a wide variety of environmental categories, environmental impact, you would need to also streamline which ones would be most relevant to you or not. Okay, so these are, maybe an illustration of how you can identify boundaries. These are being suggested for industries now when they're trying to report on their environmental impact. So some can just focus on scope 1, which are direct emissions, which are things that are directly controlled by your process. While scope 2 would be indirect emissions, such as the utilization of electricity, because you use electricity, but you don't know that it's actually generating carbon emissions elsewhere. So it's, in a way, an indirect emission. And then finally, you have scope 3, which includes all other indirect emissions that occur in a company's value chain. So scope 2 is just on electricity, while scope 3 would be other indirect emissions. Maybe if your employees go on travel, then that would have an associated environmental impact as well. Eating out and other things, So a company can actually figure out what it can focus on, so that they can change their activities and reduce their environmental impact. Okay. All right, hold on. Okay, so maybe we can have this one, and then we can have an activity. Yeah, I think I'm stretching my time. It's already 1 o'clock, but let's have this activity first. So having known that, the direct and indirect emissions, what do you think are some indirect emissions or indirect environmental impacts that happen when you make use of your mobile phone? Like when you use your phone, what do you think are some indirect emissions or indirect environmental impacts? Sorry about that. Because when you use it, it doesn't seem to be doing anything. Like we use it, we don't see anything. Scrolling social media, okay? Like it doesn't, it's not generating any emissions. We don't see any smoke. We're not generating waste when we're using it. So what do you think are some of its environmental impacts? Well, do you think that a mobile phone has an environmental impact? Yeah, so I'll start off the countdown. And then after this, maybe we'll just do breakout. Okay, I think some might need to leave because of their prayers. Okay, just one? I don't have any other responses. Okay, there, calling and texting, okay. But what about the environmental impact? Okay, those are some of the activities we do. What about the environmental impact of using your phone? What do you think? Is there an impact or none? Yeah, overcharging the phone. Yes, okay. So, yeah. Okay, yeah. Switching phones too often, correct. Yeah, so when you do these things, like when you overcharge, okay, voting is closed, that's fine. When you charge your phone, of course, we use electricity. So that's in a way an indirect impact. When we do social media, calling and texting, we also use electricity because, we use the charge of the phone. And then later on, we need to charge it again. Switching phones too often, yeah, because we will need to dispose of the phone. So it in a way, you have waste that gets generated. So thank you for your responses. So I think we should now try to go to okay, let me stop my sharing. I don't know where I placed that slide. I know I had a slide that's meant for your activity. Okay, so let me just look for it. Okay, so maybe now it's time for us to go into an activity. So we'll split into groups. And essentially, what the activity would be is to select a particular object. Let me just see if it's in my slides. Okay, can't see. Okay, hold on. Okay. Okay, so maybe we can just, all right. So let me just share my screen again. I found it. All right, so this is our group activity. So the activity would be, you'll be split into groups, choose a product, any kind of product. It can be a ball pen, it can be a shoe, I don't know, it can be your mobile phone, and then try to deconstruct, like figure out what do you need to make that particular product? You know, what are the components? Like what materials do you need so that you can make it? And then just pick one environmental impact. What do you think is the most important environmental impact for your particular product? So I think that's all. That's all what I want you to do. Can we do it in what? 10 minutes, 15 minutes, Dr. Kitain? How long do we give the students?
15 minutes, maybe.
Okay. 15
And
minutes.
so they will have time to introduce themselves.
All right, all right.
Okay.
Okay.
So
Stop. Okay, is that good for everyone now? Did everyone get that? Maybe you can just do a screen capture so that you will remember.
So I'm going to split them into 5 groups according to their group assignment. So
Yes.
please go to your group assignment, group number. Okay, so let participant choose room 5 groups. So for ITS and Kumamoto University students, please go to your pre-assigned group number. And for those students who are auditing, please join any group that you like, all right? So go ahead, everybody. So room number 1, this is for group number 1. Students assigned to group number 1, please go to room number 1 and so on and so forth. For room number 2, group number 2 students. Room number 3, group number 3 students, and so on. Go ahead, everybody. Please choose your room and then join your room, group number. Go ahead. Please remember your room. Please join your room, everybody. Thank you. So you have 15 minutes to discuss with your group mates. So for those students auditing, for auditing students, please join any room that you like, okay? From 1 to 5. Great, everybody, good. So room number 1. Great, thank you. All right. How about the others? Not to what? Narita. Bien not, you may want to go to. All right. Okay. Great. Who else? Fikri, you may join any group. Like,
I think some of them from ITS students,
yeah.
they still, how to say, they already left for Friday prior, but
I see. Okay. I understand. Not receiving. Okay. So they have until
1:20.
2:20.
Sorry, 2:20. Yes.
Okay.
Yeah, I think I stretched the time too much.
No, it's okay. It's good.
Yeah, and then I'm not sure. Do we ask the groups, maybe one or two groups to
For
to
now,
report?
or maybe next week.
Or okay.
Yeah,
okay.
next week.
Yeah. Okay. Perfect.
Then the homework I'm going to
Okay.
later, and then
Okay.
for them to do it. I gave them until 22nd of
Yeah.
October because they're also busy with other classes. So you're until. I am sending message to them. So.
Okay. I hope the instruction was clear.
Yeah. Definitely. I think they're working on it now. Very interesting lecture, Dimke.
Yeah, it's okay. It's much longer than I anticipated.
That's